Hello everyone, today we're covering section 18.2 titled Rational Exponents. Now 18.2, as you can tell, is out of order. We covered some of the other sections first in chapter 18 or module 18 because it just fits better. And now we're going to cover this one, the rational exponents. So we are familiar with radical expressions meaning expressions that have square roots in them. So now we're going to see what rational exponents mean. Now remember, the word rational just means a fraction. So when we were talking about rational expressions, we were talking about an expression such as 2x divided by x minus 1. That was a rational expression. So rational just means a fraction. Radical means root, the square root of x. That's a radical expression, and a fraction is a rational expression. So we're going to see what rational exponent means. Exponent means the power. So when we say a rational exponent, that means a power that has a fraction in it. So we're going to convert between radical form and rational exponent form, and we're going to divide rational expressions and use properties of exponents. Let's start with something that we're familiar with. So here is a radical that we have been able to simplify before. How do we do this? How do we do the cube root of x to the power of 21? Does anyone remember the shortcut? Well, we were taking the power and dividing it by the index, correct? So the cube root of x to the power of 21 is x to the power of 7. So if I write this explicitly, so this becomes x to the power of 21 divided by 3. I can write it like this. In other words, the cube root of x to the power of 21, this is radical form. If I convert it into exponential form, I can write it as x to the power of 21 divided by 3. And this here is what we call rational exponent. So a rational exponent, or a fraction in the exponent, it's just another way of writing any radical expression or any root. So any root can be written as an exponent instead, and obviously this can be simplified to x to the power of 7, but going from here to here, this is a very important property, and we can generalize that. So the general concept here is, if I have the nth root of x to the power of m, I can write that in exponential form or as a power, and that becomes x to the power of m divided by n. So the power here goes on top, becomes the numerator, and the index goes on the bottom and becomes the denominator. Okay, so let's go ahead and take a couple of examples here. It says convert from radical, so convert from root, to exponent form, and vice versa. So we have to be able to go back and forth between those two. So let's try the first two examples together. So once again, we have the fourth root of x. Well, what is the power here? This is x to the power of what? Well, there's an invisible 1 over here. So if I convert that, then this one here is going to be in the numerator, divided by that 4 here goes in the denominator. So the 4th root of x, if I convert that into exponential form, it simply becomes x to the power of 1/4. What about the other way around? 17 to the power of 1/7. Can I convert that into radical form? Sure. Here's the radical. Inside the radical, we have 17. This top part is the power, so 17 to the power of 1. And this bottom one is the index. So the 7th root of 17 to the power of 1. And we can just simply write that as the 7th root of 17. So here's a couple of examples of how we can convert back and forth. I'm going to encourage you guys to go ahead and pause the video now, do number C and number D, and I'm also going to add another one, E. How about negative 25 to the power of 1/2? So those are obviously ones that are in exponential form. They have a power, and you're going to convert that into radical form or a root. So pause the video, go ahead and try C, D, and E, and then play it again when you are ready. Okay, so this is going to be the root of 8, and now this here is the power, so 8 to the power of 1, and the bottom here is the index, 3. Which means this is the cube root of 8. I hope that when you did this, you didn't just stop right there, because the cube root of 8 is a quantity that can be simplified, correct? We know what the cube root of 8 is. What times itself 3 times gives us 8? Well, that is obviously 2. So you must simplify radicals whenever you can. So 8 to the power of 1/3 simplified gives us 2. Okay, what about this next one? We have a negative 25 to the power of 1/2. Now keep in mind that the whole negative 25 is in parentheses. That means all of it is raised to that power of 1/2. The whole negative 25, the negative and the 25. So let's build our radical. Now the whole thing, the whole negative 25 is going to be inside the radical. The top part is 1, so that's the power here. The bottom part is 2, so that's the index right there. Now we don't have to write the index 2, correct? This is just the square root, and we also don't have to write anything to the power of 1. So that is simply the square root of negative 25. So take a look at what we have here. Something to the power of 1/2 is equivalent to the square root that we're all familiar with. Yes? So now the whole negative 25 is going to be in the square root. Well, what is the square root of negative 25, guys? We know this one, don't we? It's going to be what? Not a real number. We cannot take the square root of a negative number, right? Okay, well, what about the next one? What is the difference? Well, the difference in the next one is there's no parentheses. There's no parentheses around the negative 25, which means what exactly is raised to the power of 1/2? Is it the whole negative 25? No. Only the 25 is raised to that power. So only the number that is directly before the power is raised to the power. That's the difference when you have parentheses. That means you're grouping everything here, raising it to the power. But with no parentheses, you're only attaching the 1/2 just to the number that comes before it. This negative is going to come along. Okay, so that negative is just going to stay with us. And then it's going to be negative, and then what is 25 to the power of 1/2? Well, we just discovered that power of 1/2 means the square root. So this is negative the square root of 25. Okay, well, this one is okay because we just have square root of 25. That's a positive number, right? What's the square root of 25? It's 5. So the negative is going to continue to come with us. That's going to be negative, and then square root of 25 is 5. So the answer here is -5. So pay attention to the difference between D and E. They look very similar, but they obviously have very different results. One of them is going to be a square root of a negative number, so that's not a real number, but the other one is going to be -5. Okay. Okay, now let's go the other way. So let's take this example here, 16 to the power of 3/2. Now, we have agreed that when I convert this into radical form, this 3 right here, the top becomes the power, and 2 becomes the index. Well, let's see a couple of different ways of doing it, and they're both correct, but we're going to see which way we actually want to go with. So what we have here, up here, is correct. So we're going to have 16, this 3 is the power, and the 2 here is the index. So that's going to be the square root of 16 to the power of 3. Now, if I want to simplify this, because now I have 16 to the power of 3, I'm going to put this into my calculator. 16 times 16 times 16, that's going to give me a big number. This is going to be 4,096 inside the square root. Then I have to take the square root of the big number, and that gives me 64. Now, let me show you an alternative, easier and better way of doing that. Okay, first, we're not changing the rules. This 2 is still going to be the index. We're still going to have the square root. And that 3 is still going to be the power. We're still going to raise it to the power of 3. However, what we're going to do is we're going to do them in different order. The 2 is the square root, so we're going to have a square root of 16. The 3 is the power. Now we're going to do square root of 16 and then after that raise it to the power of 3. Okay, take a look at the difference between this and this. Both of them we have a square root, both of them raised to the power, but there's a very crucial difference. In the top one, the difference is first you're raising 16 to the third power. So the difference in which order you're doing the operation. And that results in getting us a big number. The bottom one, first we take the square root of 16. Well, how does that help us? Let's see. If I take the square root of 16, what do I get? I get 4. That's a smaller number. So now I have 4 and then to the power of 3. Whereas here, now I got a big number inside the square root. You can't even do that without a calculator, can you? Then you take the square root of 4,096 and you get 64. But here, if I take the square root of 16 first, I get a smaller number instead of a bigger number. And then I can take the smaller number and raise it to the third power. Now that's an easy operation. 4 times 4 times 4, that's automatically 64. Okay, so both methods, you are getting the correct answer. However, the order that you're doing these operations makes a difference All right, so let's write those down. So the first method, if I have x to the power of m over n, like we did here, I can convert that to the nth root of x to the power of m, which is what we have here. It's obviously correct. Or the alternative method that we are going to use to simplify, because it's better and easier, is if I have x to the power of m over n, what I'm going to do is I'm going to do the root first, the nth root of x, and then after that, I'm going to raise to the power of m, just like we did here in this example. I hope this makes sense to you guys. Hope it's clear. We're going to see a couple of examples here that makes it, hopefully stick a little better. So let's go ahead and do that. Okay, this time we have 16 to the power of 3 over 4. So we're going to use our alternative method, which is the second one, which says the following. First, you take the root. This time the root is the fourth root, so we're going to take the fourth root of 16, and then we're going to raise it all to the power of 3, like so. Okay, well, let's do step by step. What is the fourth root of 16, you guys? What number, when you multiply it by itself 4 times, gives us 16? If you think about it a little bit, that would be what? 2. 2 times 2 is 4. 4 times 4 is 16. So 2 times itself 4 times gives us 16. So the fourth root of 16 is 2. So now we have 2 to the power of 3, and that's an easy one to do, right? 2 cubed is 8. If you had gone the other way around, then you would have had the fourth root of 16 cubed. Now, you would have had to do that on your calculator, because 16 cubed is going to be a big number. 16 to the power of 3, that's 4,096. So now you have the fourth root of 4,096, and then you're going to have to use your calculator for that. Find what the fourth root symbol is and put that huge number, and you're still going to get the same answer, 8, right? But once again, I hope it's clear that our method here, or our alternative method, when converting from exponential form to radical form, that would be the preferred one. Okay, so you guys go ahead and do number B and C the same way. Pause the video, do these two on your own, use the alternative method that we have discussed, and you shouldn't even have to use a calculator to do any of those. So do those without the use of a calculator, and then play the video again after you're done. Okay, let's go ahead and do it. So now we have a radical. The index is 3, so this is the cube root of 27. And then all of it is raised to the power of 2. So first step, what is the cube root of 27? What number times itself 3 times is 27? Well, if you think about it a little bit, that should be 3. 3 times 3 is 9, times 3 is 27. So the cube root of 27 is 3. So now we have 3 squared, which gives us 9. Okay. So 27 to the power of 2/3 simplifies to 9. Next one, 4 to the power of 5 over 2. So now we have a radical with 4 inside. The index is 2, so that's the square root. We don't have to write the 2 here. And then we raise it to the power of 5. So that's going to be the square root of 4 raised to the power of 5. Let's start inside. What is the square root of 4? That's 2. So now it becomes 2 to the power of 5. What's 2 times itself 5 times, guys? 2 times 2 is 4, times 2 is 8, times 2 is 16, times another 2 is 32. So the answer for that one is 32. Okay, so next we're going to use the 2 new rules of exponents, or actually the 1 new rule of exponent that we've learned, which is this one right here. You don't really need those 2. These are not new ones. They're all included in that one. So this is the new rule for exponent that we've learned, the rational exponent. However, we have many other rules for exponents that we've learned before. Power rule for products and quotients, product rule, quotient rule, power rule, zero exponent rule, and the negative exponents rules. These are prerequisites to this course, so we're not going to go over them. However, if you have not done so already, I 100% strongly recommend that you pause the video at this point and then go back and watch the review video that I made for the rules of exponents, which does go over every one of those rules in some kind of detail and gives you examples. So if you have not done so already, please go back, review that video, and then come back and continue this one after you've done so. Okay, so let's go ahead and see some examples for properties of exponents that use all of properties of exponents. So in those examples, we're going to use all of the rules that we've learned previously, plus the new one that we have learned today. Okay, it says simplify and write without negative exponents. So hopefully you recall the rules for negative exponents. Now, we do not write any final answers with negative exponents. We always write them as positive exponents. So let's see what we can do for the first one. The first one is 8 to the power of negative 2/3. So first, we need to take care of that negative exponent. What does negative exponent means? It means you flip the base. Okay, so this 8 over 1 has to be 1 over 8. So this becomes 1 over 8, and then the exponent becomes positive. So it's 8 to the power of, instead of negative 2/3, it would be positive 2/3. Okay. Well, now let's continue with simplifying. So now we have this 8 to the power of 2/3 on the bottom. So this is still 1 over, and this is the new one that we learned today. What does it mean to raise a number to a power that is a fraction? Once again, the bottom here, that's the index, so it's going to be a root. So that's going to be the cube root of 8. And that 2 here is the power. So all of that is raised to the power of 2. Let's go ahead and simplify further. What is the cube root of 8, guys? The cube root of 8 is 2. So that's 2 raised to the second power. And finally, what is 2 squared? That would be 4. So the final answer here is 1 over 4. Okay, so 8 to the power of negative 2/3 simplifies to 1 over 4. There are multiple steps there. Hopefully every step you guys can follow. The first step right here is the negative exponent rule that we know from previous course, and then the rest of those is what we've learned today. Okay, let's do another example. We again have a negative exponent. So 1 over 25 to the power of negative 3 over 2. So once again, I'll ask you, what does a negative exponent mean? It means you flip the base. Okay, so instead of 1 over 25, that's going to be 25 over 1 or just 25. We don't have to write over 1. So the base is flipped. It's going to be 25, and now the exponent becomes positive. So this is 25 to the power of 3 over 2. Once again, the first step is from a previous concept. Now we have something raised to a rational exponent, which we've learned how to do so today. The bottom part is the index, so that's going to be the square root of 25. The top part is the power, so we're going to raise all of it to the power of 3. Start here. What is the square root of 25? That is 5. Now we have 5 cubed. 5 times 5 times 5. 5 times 5 is 25, times 5 is 125. Okay, so 1 over 25 raised to the power of negative 3 over 2 simplifies to 125. All right, let's see some more examples. In this example here, it says the same thing, simplify and write without negative exponents. Now we have division of two quantities. It's the same base, x to the power of something divided by x to the power of something else. So which rule do we use here for division? There are two ways to go about this one. The first one is going to use the quotient rule. The quotient rule says when you divide, you keep the base, which is x, and then what do you do with the exponents, which are those in this case? Quotient rule says when you divide, you keep the base and you do what? You subtract the exponents. So you take the exponent for the numerator, which is 1/3, minus the exponent of the denominator. Now be careful here, the exponent in the denominator is already negative. Yes, so when you subtract it, it's going to be 1/3 minus this negative 3 over 4. Okay, minus minus. What is that going to give us? Let's do that on the side. 1/3 minus negative 3 over 4. When you have a negative negative, that becomes what? Plus. So that's the same thing as 1/3 plus 3 over 4. Okay, so now we're adding two fractions. How do we do that? Well, we cannot add fractions unless we have what? Common denominator, correct? So what's the common denominator here? That's going to be 12. So we need to write this as something over 12 plus something over 12. Right? How do we do that for the 3? We're going to have to multiply it by 4, which means we need to multiply the top one by 4 as well. What about this 4 on the bottom here? That has to be multiplied by 3, which means the top one also multiplies by 3. So what do the fractions become? The first one becomes 4 over 12 plus 9 over 12. Adding these two together, what do we get? 4 plus 9 is 13. So we get 13 over 12. And that's what this exponent is going to be. So we're going to write this as x to the power of 13 over 12. And that's all we're asked to do. We're asked to write it without negative exponent. Now, sure, If you want to, you can go a step further and write this in its radical form. That would be the 12th root of x to the power of 13. That's not wrong, but that's not really what we're asked for. Okay, this is not simplification. This is just changing it from exponential form to radical form. So it's not wrong, but this is an unnecessary step. And I definitely would not do anything extra if I don't have to do it. Okay, now I mentioned to you guys that there's another way of doing that. Let me just show you briefly. If I start here with x to the power of 1/3 divided by x to the power of -3/4, what you can do is you can take care of this negative exponent first. Well, if I have a negative exponent, that means they're reciprocal, right? So if this is on the bottom with negative exponent, where does it go? It goes to the top. So this can go up here and the exponent becomes positive. Okay, meaning I can write this as x to the power of 1/3 times x to the power of positive 3/4. Now, what does that leave on the bottom? Not nothing, it leaves 1. We don't have to write the 1, but it's still there. Okay, well, how do I do this now? X to the power of 1/3 times x to the power of 3/4. Well, the rule says, because this is multiplication, when you multiply, you keep the base, and what do you do with the exponents? You add them. 1/3 plus 3/4. Okay, so quotient rule here, when we divide, we subtract. Product rule here, when we multiply, we add. Again, this is in the review video that I sent. All right, and now we can add 1/3 plus 3/4, which is what we actually did before. What does that give us? Same exact answer, x to the power of 13/12. So this is the beauty of math, is as long as you're doing the correct math, as long as you're following the right steps, even if you do it differently than somebody else, you're still going to get the right answer in any way, because the rules for math they don't change. They apply to every situation. So those are universal rules that you can always use. Okay, let's do this next one together. We have x to the power of -15 times x to the power of -2/3 times x to the power of 4/3. This is all multiplication, guys. We're multiplying all of these x's together. The base is x. So which rule do we use when we multiply? When we multiply the base, it's the product rule. It says to do what with those exponents? Add them. So we're going to keep the base, and we're going to add -1/15 plus -2/3. Well, I don't have to write plus negative, it's just minus. So -1/15 minus 2/3 plus 4/3. And that's going to be all in the exponent here. -1/15 minus 2/3 plus 4/3. It's 15, excuse me. Okay, well, this is quite some addition and subtraction of fractions here, so let's do that on the side. -1/15 minus 2/3 plus 4/3. Once again, we're adding and subtracting fractions, so we need the common denominator, which is going to be what in this case? We have 15 and 3 and 3, so the common denominator will be 15. So we're going to have to write everything here over the same denominator, 15. The first fraction, we don't have to change anything. It already has the common denominator. But what about the second one? We need to multiply it by 5, top and bottom. And the third one, we also need to multiply it by 5, top and bottom. So that's going to be 10 over 15, and that's going to be 20 over 15. So what does that give us? So now we have -1 minus 10 plus 20. So that gives us positive 9 over 15. Always, when you get a fraction, make sure that you simplify it. Those two can be simplified. We can divide them both by 3. So that gives us 3/5. And that is what we get here in the exponent. So that becomes x to the power of 3/5. That would be the final simplified answer. Once again, you can turn it into radical form, but there is no need to do so. Okay, it says 7/15. Did I do any math wrong here? Let me just make sure. I want to see if that's a typo from me or from the answer here. So -1 over 15 minus 2/3 plus 4/3, -1/15 minus 10/15 plus 20/15. 20 minus 10 is 10, minus 1 is 9. Well, I don't really see any typo on my part or a mistake. If you guys catch a mistake, definitely let me know. It's possible that I've made a mistake somewhere, but based on that, those calculations, I don't see it right now. So I'm just going to assume that this is the correct answer and this here is the typo. Okay. This one here, guys. So I'm going to encourage you to pause the video right now. Go ahead and do this one on your own. This is very similar to the one that we just did. So try this one on your own and then play it again when you are done. Okay, once again, we have multiplication. With multiplication, we use the product rule, which says add all of these exponents together. So let's do that on the side. We're going to have 1/6 plus negative, which is just minus 2/3, and then minus 1/3. Once again, we can get the common denominator, which is going to be 6. The first fraction doesn't have to change. What about the second one? Needs to be multiplied by 2, top and bottom, so it's 4 over 6. Third one times 2 top and bottom, so it's 2 over 6. So what do we get here? We get 1 minus 4 minus 2, so that would be -5/6. Okay, so that's what we have for this one. This is going to be x to the power of, once again, we're just adding those, 1/6 minus 2/3 minus 1/3, which means it's x to the power of -5/6. Well, this one is going to require us to do one extra step from the last problem, because we end up with negative exponents and it says write without negative exponents. So what can I do here? What is the rule for negative exponents? How does it become positive instead? Again, you flip the base. So instead of this being x or x over 1, you flip it into 1 over x. So it's 1 over x to this power here, and the power becomes positive. So it's 1 over x to the power of 5 over 6. Okay, and that would be the final answer for this one. Okay, let's take a look at the next one. The next one we have x to the power of 7 over 4. All of it is raised to the power of 6 over 5. Which rule is that, guys? This is the power rule, or power of a power. So what is the rule here? When you have an exponent raised to another power, what do you do with the exponents? You multiply them. Okay, that's another rule from our prerequisites. So you keep the base and you multiply the exponents together. 7 over 4 times 6 over 5. Okay, let's go ahead and do that one on the side. What's 7 over 4 times 6 over 5? Well, we know how to multiply fractions, don't we? What is the first thing we do? First, we reduce any factor in the numerator with any factor in the denominator. So we got a 6 here and a 4. We can divide them both by 2. And then after we reduce, we multiply. Top times top and bottom times bottom. So what does that give us? 21 over 10. So that gives us x to the power of 21 over 10. And that would be our final reduced simplified answer. Okay, based on the same rule, you guys, go ahead and pause the video and do this next one on your own, and then play it again when you are ready. Okay, so one more time we have the power rule. So x squared, all of it is raised to the power 5 over 12. So once again, what are we going to do with those exponents? We're going to multiply them. 2 times 5 over 12. Let's do that on the side. How do I do that? Well, if it makes me feel better, I can put this 2 over 1, and then I can multiply the two fractions as I normally would. First, you can reduce. This time is easy. 2 divided by 2 is 1. 12 divided by 2 is 6, and that gives us just 5 over 6. And that would be our final answer, x to the power of 5 over 6. As you can see, guys, in that section, in order to be successful here, it requires our knowledge of all of the rules of exponents that we've learned previously. The power rule, the quotient rule, the first one was the product rule. The product rule is for multiplication. The quotient rule is for division. And then the power rule is for raising it to a power, and also negative exponent rule. So all of those together is what we've learned previously. And now we're adding also another one, which is the rational exponent rule, and that's the new one that we added today. So to be successful here, we need all of those together, plus we also have to be very good with operations of fractions, which I did also send you a previous video about that. Adding fractions, subtracting fractions, multiplying, dividing fractions. So if this is, again, not your strong point, you can go back and rewatch that video and review it one more time. But all of these together are required for us to learn new things and be successful at this section and also other ones and new concepts going forward. Thank you guys for your patience. This is it. Let me know if I can help you in any way.